Hi, B and Alex. How are you all doing today? So I'm going to go ahead and start in on finding the area under a region here. So this is the whole reason that we are doing these integrals. Okay, so we've been doing these integrals for a while now. At least I have. I'm not sure if y'all been watching the videos or not, but at least they're out there if you ever want to get caught up. So the reason for doing these integrals is because we want to be able to find the area underneath a curve. Okay, and our curve is going to be bound by some stuff. In example 1 here, they give us a picture. Okay, so this is a picture that I drew out of one of the book examples. They give us the equation, y equals x minus x squared, which looks like this. Okay, but what they're doing is they're bounding it by the x-axis, they're bounding it by the y-axis. Okay, so we're not interested in anything in this quadrant, or this quadrant. We're really only talking about the top right quadrant. Okay, so this is real world application kind of. We would not be doing things in the negative areas, so we're really only interested in the positive area up there in quadrant 1. Okay, so what we have to do here is very simple. We're going to set up an integral, a bounded integral like we did last week, and what we need to say is we're going to do the integral from 0 to 1. The reason we're doing the integral from 0 to 1 is 0 is our starting place right here at the origin, and we are trying to find the area under the curve up until x equals 1. Past 1, it's down in the negative, so we're not really interested in it. Okay, so that's the reason that we choose from 0 to 1, because that is the range that our area, or that our picture is bound by. Okay, then I can just throw in my equation, x minus x squared, and I've set up a bounded integral. That's very simple to do, and all I've got to do is just integrate and then plug in the numbers, and we're out of here. Okay, so if I integrate, integrating x, I would have to raise the exponent 1 and then divide by it, so that would be x squared over 2. And then I would have to do the same thing on the x squared, so I would raise the exponent to x cubed and divide by 3. Okay. So this is this is integrated already, so that means we can use a bracket now from 0 to 1 still. And we plug in the top number and then subtract what we get when we plug in the bottom number. Okay, so plugging in the top number, I would get 1 squared is 1 over 2, so that's 1/2 minus 1 cubed would be 1 over 3, so 1/3. So the top would output us here. I'll put top, bottom. So the top, this is actually a 1/6, and then we subtract whatever we get when we plug in the bottom. So the bottom would be 0 squared, which is 0 over 2 is 0, minus 0 cubed is also 0 divided by 3, which is 0. Sorry, I didn't mean to put this mark. All right, so we got 0 minus 0 here, which is 0. So that tells us 1/6 minus 0 is 1/6. So that means the area under that region, okay, the shaded in region that I have on my picture here is 1/6. Okay, so if we were talking about inches, we would say inches squared, or if we were talking about yards or something like that. Okay, we could say units squared if we really want to get technical, but for right now, just 1/6 is fine. Okay, so hopefully you were able to understand that. Remember, the reason that we set up our bound integral over here from 0 to 1 is because 0 is the starting place that our graph started to be bound by, and then 1 was where it ended. Okay, let's take a look at another example. This one does not give us a picture, it just gives us some things to create our own picture with. Okay, so what I'm going to do first is give us a rough sketch of what 5x squared plus 2 looks like. Okay, it looks like this. Okay, so it's a parabola. It's vertically stretched a little bit because of the 5, but then the plus 2 takes it up 2 places. Okay, so rough estimate, it looks something like this. Again, in the last picture, we weren't interested in any of the other 3 quadrants. What these 2 things up here, x equals 0 and y equals 0, tells us is that we want to be bound by the line x equals 0, which is this line, and we want to be bound by the line y equals 0, which is this line, telling us that we're not interested in this section, not interested in this section, not interested in this section. Okay, so only quadrant 1. Based off of our stuff up here. Now, the other one up here that we were given is x equals 2. Okay, so I need to put 2 tick marks down here So x equals 2 is right there. So really what's going on is we are going to be interested in, I'm going to outline it in blue. We are going to be interested in this section right here, okay, because that's bound by the x-axis, that's bound by the y-axis, and that's bound at x equals 2, okay? So let's set up an integral for this. I'm going to have the integral, this time I'm going from 0 to 2 because that's where my situation is bound from. And then I've got 5x squared plus 2. So let's integrate. Integrating 5x squared, add 1 to the exponent, and then divide by it. So that's going to turn into 5/3 x cubed. I prefer to write it like this than put the x in the top, but whatever y'all want. And then, you know, whenever you have a whole number, you just have to add an x to it. Okay, that's from 0 to 2. So let's plug 2 in. Okay, 2 cubed is 8. 8 times 5/3. 8 times 5/3 is 40 over 3. And then we've got plus 2 times 2, which will be 4. So 40 over 3 plus 4 is 52 over 3. So that's for the top. For the bottom, I'm plugging in 0. So 0 cubed is 0 times 5/3 would be 0. Whoops. Then plus 2 times 0 would be 0 again. So that's 0. So we got minus 0. So 52 over 3 would be the area for this one. That works out to be 17 point something. 17.33. Okay, so answer it as fraction, answer it as a decimal. It doesn't matter to me. This is the actual useful part behind the definite integral. Okay, so we're going to be using this moving forward to find the area under curves. That's what it's really made for. We'll start using it in application and stuff moving forward also. Okay, so hopefully you were able to understand this. Let me know if you got any questions or if you even watched the video. Let's work on page 328. Numbers 39 through 48. All right, so if you got any questions, let me know. If not, I'll talk to you next week.